Everyone. In this video, I'm going to explain number one, the concept of memory management when we talk about arrays. Number two, I'm going to talk about parallel arrays. And number three, we're going to talk about uh, two-dimensional arrays and how to use nested for loops and while loops to um, tackle two-dimensional arrays. So the first is basically memory management. So whenever we declare an integer in the memory, that integer takes up some space, and depending on what um, variable you're declaring, um, a respective amount of memory is saved, is reserved by the operating system. So if I say int a, in most cases, this will reserve 4 bytes in the memory. These 4 bytes are pointed to by this variable named a. Now, wherever in this program you say a, it basically means that memory location. So whatever is on that memory location is represented by this variable named a. It's a variable because the value can change compared to a constant, which basically means the value cannot be changed. So, but this is just a simple primitive data type. It's an integer. What about an integer array? How is the memory managed for an array? Well, think about an integer array as a stack of um, multiple integers, but really in the memory they are consecutive memory locations. So this is an important concept when we talk about C++ arrays, or for that matter arrays in most languages. um, Arrays are composed of consecutive memory locations. So uh, those uh, five, let's say I declare an array of 5 elements. These 5 elements are going to be consecutively placed in the memory, and this is the reason why index numbers work. Now when I say array 0, that is the first memory location. Array 1 is the next memory location. So I can always also say uh, uh, 2, 3, and 4, right? Now, uh, where is that memory location? Can we find out that memory location? Sure, we can. And that memory location is represented by the variable itself. So let's say this, and let's say you want to find out where in memory is your array. So you're going to say just print ARR, and ARR basically points to first memory location. So the first memory location. So technically speaking, if I say ampersand ARR, this is essentially the same thing. It is also pointing to the first memory location. So here's how we break this. This part means the first memory location, and we know this because we already have seen a cout statement in the previous video where we can print one of these memory locations. So this prints whatever data there is on the first element, first memory location. Now this statement is a bit different. There's an ampersand in the beginning. An ampersand basically means memory address. So this points to the first memory location, and what this is going to print is exactly the same thing. What this means is the first memory location's address. Okay, so prints the same address as previous statement. And so if I just do +1 from this, then I go to the second integer, which is array 1. If I do this +2, then I go to the third integer, which is array 2. So that's how you can keep moving. So that is how memory is managed for one-dimensional arrays, the consecutive memory locations. Now, what about parallel arrays? So let's say we have a situation where we have students in a classroom, and in one array I save the registration number, Okay, and in another array, which happens to be a character array, so it's an array of characters, byte after byte, I save the letter grade. And because these are parallel arrays, they have to be of the same size. Okay, so let's just get that out of the way. Now, parallel arrays essentially mean that each element in one array is corresponding to the same index in the other array. So if I have to populate these, I'm going to say reg number 0 is the registration number of the first student, and letter grade 0, so letter grade for the student at index 0 in the other array is A, for example. Okay, similarly, registration number 1 is this, and the letter grade for registration number that which is represented by the first index is C, for example. Okay, so in reality there is no data structure called parallel arrays. Parallel arrays are made up of regular C++ arrays, but they have a relationship between them. So this array at index 0 is talking about the same student that this array at index 0 is talking about. So these two have a relation, and most of the times when you use this, you're going to use this in conjunction with each other. Okay, so yeah, so that was the concept of parallel arrays. In the next video, I'm going to talk about two-dimensional arrays and how to use nested loops to work with two-dimensional arrays. Thank you for listening. If you like this video, please hit the like button.